Good morning, students. This is Dr. Anton Xavier Lewis, Assistant Professor of Karunya Institute of Technology and Sciences from the Division of Aerospace Engineering. In this lecture, we are going to talk about low bypass versus high bypass turbofan engines, and this topic, which is coming under the subject AE 2012 propulsion. The intention of this subject is to have a wide knowledge about the propulsion of the aerospace vehicles, and the reason behind why I'm choosing this topic is to have a clear cut about the turbofan engine and especially this low bypass and high bypass. Let's get into the topic. The overview of this presentation is we are going to discuss about the definition of the turbofan engine and what is the bypass ratio, which is the most wanted keyword of this turbofan engine, and separate topics of both low bypass and high bypass turbofan engines, and the key difference between both low and high bypass turbofan engines, followed by the advantages and disadvantages, then the examples of both low bypass and high bypass turbofan engines, and finally we are concluding which one will be preferred for the specific application, right? So first of all, what is turbofan engine? So this is a simple definition which is taken from the internet, and you might have also gone through the same definition, but there is a significant difference compared to other rough definitions about the turbofan engine. So as per the definition which is given here, you can see the turbofan or fan jet. Actually, there are a lot of difference between turbo and its combo. So here the turbo is coming. Turbo is nothing but the turbine. Okay, because the turbine, which is the power generation source, which is generated and combined with the fan. So you can see the fan in this picture. So which is I think you can see the pointer. So the fan is playing a major role here along with the turbine. So we are calling as a turbofan engine. So this is also coming under the air breathing engine category, and nowadays it is widely used in aircraft propulsion, commercial jets, war jets, depends upon the application. And you can see the word turbofan is the combination as I mentioned earlier. Okay, and corresponding components are mentioned here. You can see there is a fan at the front of the engine, followed by a low bypass, low pressure and high pressure compressor section, and the combustion chamber, followed by a high bypass and high pressure turbine and low pressure turbine. So we can say as this is the twin spool. Okay, so you can see the shaft, both different shafts will be rotating in the opposite direction. Okay, so that rotation also that should be considered. So both both the shafts will be rotating in opposite direction in order to avoid kind of effects, rotary effects. Okay, so both will be rotating in the opposite direction and will be balancing the engine complexities. And you can see here green, one spool is in a green color and another one is in a maybe purple color, and you can see apart from the fan, remaining all components seems like the turbojet engine. Okay, so it seems like one fan which is fitted at the front of the turbojet engine. Okay, and there is also another one reason to have this twin spool. Okay, twin spool, and maybe this picture which shows the old type of the turbofan engine, and nowadays after upgraded with the gearbox in between this fan and the low pressure compressor section. Okay, right? Maybe other lectures I can show the picture of that gearbox and the significance of those gearbox. Okay, we can discuss it, right? Yes. So now come to the bypass ratio, which is the most important keyword in this in this turbofan engine topic. So you can see most of the students, most of the students will do the mistake in order to understand this bypass ratio. Okay, it is nothing but there is a ratio between the air, you can see here, mass flow rate of the bypass stream. So that should be coming in the numerator, and the denominator is mass flow rate entering the core. Okay, so you can see here at the numerator, mass flow rate of the bypass stream. Okay, it's all about the mass flow rate. Okay, we know that F is equal to, as per the Newton's second law, F is equal to m into A. F is nothing but the force, and here the force is the thrust. Okay, so the maximum thrust can be generated by this bypass, by this turbofan engine with the help of these bypass air stream. Okay, so the bypass ratio is nothing but the mass flow rate of the bypass stream to the mass flow rate of the air entering the core. Okay, a core is nothing but through the engine of the engine. So of the engine divided by through the engine, mass flow rate of the engine, mass flow rate through the engine. So that is called as a bypass ratio, and here some examples are given. That is 10 is to, if the bypass ratio 10 is to 1 in the sense, which is mean that 10 kg of air passes through the bypass duct for every 1 kg of air passing through the core. Okay, so that's we called as a 10 is to 1, and the difference also we can see. Based on the difference, we can able to differentiate low bypass and high bypass turbofan engines, right? So I hope you can understand, and maybe some other components you can view through this picture. Fine. So now it is coming with low bypass turbofan engine. So what is low bypass turbofan engine? This is also a schematic picture which explains the bypass stream path. Okay, which is very the less dimension. Okay, less size. Okay, so you can see the definition. Low bypass turbofan engine is a type of jet engine commonly used in military aircraft. This is a keyword which is mentioned, military aircraft. Okay, so we can also see the advantages, applications later on this lecture, but along with that also you can see here military aircraft and some high performance commercial aircraft. So you can keep it in your mind, this low bypass turbofan engine is suitable for high performance commercial aircrafts. Okay, high performance commercial aircrafts as well as the war jets, right? And you can see here these engines are designed to provide high thrust with relatively compact size and weight. Okay, so that is the requirement here. So based on that requirement, making them suitable for applications where speed and performance are critical. Okay, speed and performance are critical. So it is not mean that the low bypass turbofan engine is producing maximum thrust. Okay, so low bypass turbofan engine, it won't produce maximum thrust, but it will exhibit or it will show high performance. Okay, in all all kind of operations, right? So that's what we called as a low bypass turbofan engine, and the bypass will be less. Okay, bypass airflow will be less, right? And so the limit is 2:1. Low bypass turbofan engine, the limit is 2:1. The ratio will be 2:1. So 2 kg of air mass which is passing off the engine or bypassing the engine, and 1 kg of air is passing through the engine. Okay, 2:1. Somewhere I have mentioned in the key differences slide. I'll show you. Okay, so let's move on to the next slide. Yeah, high bypass turbofan engine. It is also the similar to that, but only the difference is it is producing maximum thrust. Okay, maximum thrust even at low speed. Okay, even at low speed, because of the reason you can see here, the bypass ratio will be higher. Okay, bypass ratio, the bypass path will be higher compared to the core. Okay, right? So the bypass ratio will be starts from 4 is to 1. Okay, for the high bypass turbofan category, 4 is to 1. So at the initial range starts with 4 is to 1. So 4 kg of bypass air and 1 kg of air which is passing through the engine core. Okay, so I hope you can understand. So that is the meaning of high bypass turbofan engine. You can see the definition over here, and advantages also mentioned here, as well as I have added another few slides in order to specifically mentioning those advantages of high bypass turbofan engine. So you can see here, these engines are designed to be highly fuel efficient. Okay, fuel efficient in the sense it won't be that much consuming the fuel. Okay, because maximum bypass ratio is provided. So the maximum amount of air, okay, maximum amount of air can be extracted by the fan, and those air is passing through the bypass path. Okay, through the bypass path, right? And as well as quieter, okay, quieter than their low bypass counterpart. I'll explain in the upcoming slides. Yes, okay, so these are the key differences you can see here. As I mentioned, the low bypass turbofan engine, which is 2 is to 1, and the high bypass is 4 is to 1. Okay, I mean 2 is to 1, that is the maximum, and 4 is to 1 at the initial level. Okay, and also it is the range will be varying 4 is to 1 to 8 is to 1. Okay, right? And you can see here the fan size will be smaller since the bypass path is less. Okay, so the fan size will be less compared to the high bypass turbofan engine fan. Okay, so here the fan is larger and high specific thrust. Okay, high specific thrust per unit area. Okay, thrust per unit area, which is high because the area is less, and within that area the low bypass turbofan engine is producing more thrust. Okay, but compared to the whereas in the high bypass turbofan engine, here it is low specific thrust, but overall thrust is huge. Okay, overall thrust is huge. Overall thrust in the sense it contains both of the engine on the engine. Okay, through the engine core, of the engine core. Okay, so both combined we can call it as a overall thrust. Okay, that's what the overall thrust is huge, but specific thrust is less compared to the low bypass turbofan engine. And as we mentioned earlier, this is less fuel efficient because it is consuming more fuel in order to produce that much amount of thrust, and more energy is used to accelerate the air through the core. Okay, but in the high bypass turbofan engine, more fuel efficient because the bypass ratio is higher. Okay, so the mass flow will be higher, which is enough to produce more thrust, and very minimum amount of fuel is used. Okay, and the last difference is noise. Okay, the noise level is high. Okay, because of the higher exhaust velocity. Okay, the exhaust velocity will be utilized to produce more thrust. Okay, in the low bypass turbofan engine, so the noise level is high in the low bypass turbofan engine, but in a high bypass turbofan engine it is quieter. How it is quieter? Okay, you may ask the question, how it is quieter? Because if you are seeing that picture of the high bypass turbofan engine, which has maximum bypass ratio, and that maximum airflow, okay, maximum bypass airflow will suppress the noise level of the exhaust. velocity, okay, exhaust gases, right? So it is acting, that will be reducing the noise level of the exhaust gases, okay, right? That's what we can say as a quieter. And advantages, coming into the advantages and disadvantages, you can see here based on the performance, based on the properties, okay, based on the characteristics of both low bypass and high bypass turbofan engine, we can see some points may be repeated. Okay, we know that high specific thrust suitable for high speed and high performance application. That's what you're using this low bypass turbofan engine for the military applications. Okay, military applications, right? And disadvantages, we know that less fuel efficient, noise, and operating cost is high. Whereas high bypass turbofan engine, it is fuel efficient, quieter, and lower operating cost, environmental friendly in a noise perspective. Okay, so it is suitable for commercial applications, uh, commercial jets, okay, widely used, and with a less fuel consumption, it can able to produce more thrust. And the disadvantages, it is larger because as we mentioned, the fan length is huge, okay, the size of the fan is huge, and low specific thrust, and it cannot be use or suitable for the supersonic speeds, okay, right? Why not supersonic speeds? Any guess? Because the lower specific thrust, and at supersonic velocity there may be a chance of having a shock waves, and this high bypass turbofan engine is not optimized in order to tackle, in order to manage the shock waves, okay. So it will be definitely affecting the engine performance. So this high bypass turbofan engine cannot suitable for the supersonic applications. And maybe the real world examples you can see for the low bypass turbofan engine, you can see here the bypass will be very less in size. So it is exactly outer view, it seems like a turbojet engine, but it is a turbofan engine. You can see the fan size is less, okay, the frontal area is also less. It is F-16 Falcon, used in Falcon and Concorde, okay, those days. And for high bypass, you can see exactly this picture, you can see the bypass area which is huge, okay. So it is used in commercial jets, especially the Boeing 777, Airbus 380, okay, and so on. So coming to the conclusion, eventually the low bypass turbofan engines are optimized for performance, okay, performance and speed, and exclusively can be used for military and high performance aircrafts, okay. Contrast, the high bypass turbofan engines are optimized for fuel efficiency, okay. That's what we cannot use this high bypass turbofan engine for supersonic application, and as well as commercial applications, the noise level is less, so it is most wanted, okay, most wanted objective of the commercial applications. So the noise is less, and can be used, it is needed for environmental considerations, and ideal for commercial aviation and transport aircraft, okay. So both are having its own advantages and disadvantages, okay. So we can conclude this, and we'll see in some other propulsion topic, okay. I hope you have understand the clear definition of the turbofan engine, low bypass, high bypass turbo fan engines, and the differences, bypass ratio especially, okay. We'll see you in the next video. Thank you, bye.